All right, hello once again. This is Jeff Scott of Rankin Technical College. I have been going over the PowerPoints and writing some code for Farrell's Visual C Sharp, Microsoft Visual C Sharp 2015, and Introduction to Object-Oriented Programming. I've gone through all 14 chapters of PowerPoints, and for the last 10 or so chapters, I'm writing some code examples too. I recently did two examples for Chapter 9 on inheritance, where I did a simple inheritance program, actually two different inheritance programs, one which was done as a console application and one which was done as a GUI or graphical user interface application. For Chapter 10 here, what I'm going to do is I've already written the code, ran the program, and it works, but I'm going to kind of decompose it and try to explain to you what I did here. All right? So, our main is just called program.cs, and what I want you to see in here, because it's very similar to the example that I had done, or one of the examples I had done previously, and that is, in main, notice, create some subclass objects. So in other words, I'm first going to create an employee class. Then based off of that employee class, I'm going to create an hourly employee class. Then in my main, I'm going to actually create a bunch of those employee objects. In fact, 6 of them. All right. And then to show that this could be handled polymorphically, because right now, all I have is an hourly employee that's of type employee. But I could have commission employees, I could have pieceworker employees, I could have salesperson employees, whatever it happened to be. All right, so after I go and create or instantiate these 6 employee objects, then I stick all of them into an array. Okay, so I create an array that's going to hold 6 objects, and then I stick all the objects in there. Then I go through, and for each object, I write out the information about the object itself. In other words, what should print, if this works, is the person's first name, their last name, their employee code, which in this case is always a 1, the number of hours they worked, and their hourly rate. Well, if we look at this, because I thought I kept the run, but maybe I didn't. So let's just run it again. All right, so processing employees polymorphically, and that code that you see right there, I shouldn't have done that. That processing employees polymorphically, that's from right here. Processing employees polymorphically. All right, but after we process them, for each employee, there's their name, there's their code, their hours worked, their hourly rate, and hours worked times hourly rate gives you the gross pay. So you can see, and in the third employee here, Ed Eck, looks like I've got 5. I thought I had 6 employees. 1, 2, 3, 4, 5. I do have 6. All right, so for the fourth employee here, Ed Eck, he worked 50 hours. So he has 10 hours of overtime coming at time and a half. So he made $550. All right, Kate Black had 40 hours of overtime coming. And that 40 hours of overtime was at $30 an hour, which is time and a half. So that's $1,200. And then her 40 times 20 was 800. 1,200 plus 800 equals 2,000. Hopefully you get the idea as we're kind of waltzing our way through here. So rather than going over main anymore, let's take a look at the employee class. All right. So the first thing we have in there is an employee class. And if you look where the cursor is blinking there on line 9, you'll notice the word abstract in front of class employee. By putting abstract in front of that, what we're saying is that class employee is an abstract class. Well, what does that mean? That means that it's illegal in main for us to instantiate or create a new employee that's of type employee. Notice how hourly employee is okay, but if I change that from hourly employee, if I change that to just employee, I should get an error. All right, and what does it say here? cannot create an instance of the abstract class or interface employee. Because once something like that has been made and has been created, and you have said that it is abstract, that means that it cannot be instantiated. So I cannot new it, so to speak. Now, we could have, like I said, just imagine we had 3 types of employees who worked for our company. Okay, right now we only have hourly employees, which we're going to talk about in just a couple minutes. But imagine, if you would, we had 3 different types of employees. Okay, we're going to imagine that we have hourly workers, and they make a minimum hourly wage, and there might even be a maximum hourly wage. They work a minimum number of hours, and maybe they could only work a maximum number of hours. And their gross pay is going to be their hours worked times their hourly rate. If they work more than 40 hours in a week, they get an overtime rate of time and 1/2 for all of those hours that they work that are over 40. Okay, so that's our first type of employee. Then with our second type of employee, we're going to say that that second type is a commission employee. And if they're based on commission, let's say that they still have some kind of they make a minimum salary a week, whatever it happens to be. And they have a maximum salary per week, whatever that happens to be. But over and above that minimum and maximum salary, they get a certain percentage of their sales that they make. So if they get 10% and they sell $10,000 in a week, $10,000 worth of a product, and they get 10%, they would make an extra $1,000. Then finally, let's imagine we've got a third type of employee. They're a piecework employee. So they get paid a certain amount for each piece that they make per hour. So we could imagine that they have, for example, there's a minimum number of pieces they can make and maybe even a maximum number of pieces they can make. And maybe there's a minimum that they make for each piece and a maximum they make for each piece. Okay, again, we could have other employee types other than that, but for now we're just going to imagine we have those 3. And of those 3, I'm only going to show you the first one. So you could go back if you wanted to and add the other 2. So what we're saying is any employee, whether that employee is an hourly employee or whether they're a commission employee or whether they're a piecework employee, any employee that works for the company has these 3 traits. They always have a first name, they always have a last name, and they always have an employee code. You'll notice that the first name and last name are strings, which you'd probably imagine. And the last one is an integer. So if it's a 1, they're an hourly worker. If it's a 2, they're a commission worker. And if it's a 3, they're a piece worker. So if we added another type of worker, I mentioned before, like a salesperson or something like that. Or let's say we added another type that was manager, as an example. Then manager could have an employee code of 4, but they'd still have a first name, a last name, and some kind of employee code. All right. Then we're saying for each one of these, the first name, the last name, and the employee code, we have our initializers, where we'll return or set the first name, where we return or set, so that was return or setting the first name. This is return or setting the last name, and this is return or setting the employee code. Now that should make sense to you from the example that we went over back in Chapter 9, or at least my hope is that it does. All right, then we have a constructor. We have just, again, a single constructor rather. So we're expecting that whenever we create an employee object, and we remember we can't technically create an employee object, but any employee object has a first name, a last name, and an employee code. We've already discussed this. Later on, we'll look at the toString method. And if you remember, when I ran this, and I'm going to come back, hopefully I can do what I want to show you here. Those are those employees, Okay? And if we look at this, I want to move this over, but unfortunately it's not letting me move it over any further than that. All right. So when we call this toString, this is the stuff we're getting here. So we've got 0 and 1. Oh, I'm sorry, I have to pause for just a second. All right, sorry about that. So again, the idea behind this, what I was trying to show you here, was right here we're saying, remember these numbers in curly braces are placeholders. So placeholder 0 is first name, placeholder 1 is last name, and there you get the first name and the last name. Placeholder 2 is the employee code, and there's the code. All right, so we're getting all that stuff. Remember, what a class is a template. What an abstract class is it says we're going to build other classes off of this abstract class, and they will all have access to anything that's in this class that's public. You'll also notice at the very bottom we have an abstract method with no implementation in it. It just says public abstract double gross pay. What that means is that any class that extends or is a child of employee must have a gross pay method in it. That gross pay method must be public, and it must return a double. All right? So again, taking one more time from the top, you get these typical using statements. Here are our instance variables. So we're saying that each and every employee, regardless of the type of employee they are, will have a first name, they will have a last name, they will have an employee code. Then for each of those three fields, we have our object initializers. So here is our object initializer for first name. Notice we're not doing any validation checking. So we're supposing that everything that gets entered there for a first name is valid. In the same way, the only difference between this right here for first name and this right here for last name, so the only difference between those two is the fact that the previous one said first name and this one says last name. All right? And remember, inside of the gets and sets, we always use the lowercase version because that represents our instance variable. Okay? But the name that's here is the name of the initializer, which, although it doesn't have to be the same, except for the caseness, it typically is. And then finally, we also have our object initializer for our employee code. Now, the only difference between this object initializer and the other ones, remember, that returned a string, but this one returns an integer because, again, employee code was set up to be of type integer. Did we have to do that? Could we have made it a string? Certainly. But it was made an integer just to show you a different variable type in this class. Then in our constructor, all we're doing is we're saying whatever so these variables that are right here, those variables, those first name, last name, and code, those are going to be the variables here. First name, last name, code. 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 Now that has to start making some sense to you. All right? Okay, and then finally we have our overridden toString method, and I already showed that one to you. And we have an abstract method. So even though this class is set up as an abstract class, there's only one method in here that's actually defined as being an abstract method. That's totally legit to do it that way. But again, the key kind of point here is that any employee that's going to be extended from this class, and we're going to show hourly employee in just a minute, Must have a first name, must have a last name, must have an employee code, and must have a gross pay method in it. So let's take a look at that one. Okay, so the first thing to notice is we've got what? Class hourly employee colon employee. So again, what does that mean? That literally means, that literally means that hourly employee is a child of employee. In Java, we would say, instead of using the colon, we'd use the word extends. But remember that inheritance shows an is a relationship. And if that confuses you, what that just means is an hourly employee is a employee. All right, so it'll have access to everything that was public in the employee class. Now, you'll notice that I put a bunch of constants in here. Did we have to do this? Certainly we did not. But I said that any employee works a minimum of 0 hours a week. Maybe they're sick, maybe they're on vacation, whatever. But they work a maximum of 84 hours a week. All right? And the way I came up with that is I said even if they work 7 days a week for 12 hours a day, that's 84 hours. And the default number, so if we put, what you're going to see later is if we somehow break this rule, so if we enter something less than 0 or something greater than 84, we'll just set it to the default, which is 40. All right, then we say the minimum rate is 0. Maybe the person's a volunteer. All right, so they don't make any money. And the maximum rate is 1,000. So that's the most somebody can make. And again, when you look at that, you might look at that and go, well, those are kind of stupid numbers. You wouldn't really see anything like that. I made all this up. All right, this has absolutely no rhyme or reason to it as far as those numbers go. I just literally made them up. And again, that's not what's important here. Not at all. Those values are not important. The idea that you understand how to create a class based off of another class, like how to create the employee class, hourly employee class rather, based off of the employee class, that's what matters. So the minimum rate for somebody would be 0. The maximum rate for somebody would be 1,000. The default rate, so again, if we happen to put in a number that's less than 0 or greater than 1,000, or we don't know what the value is, the default rate will be 10. Then we have max non-OT, and that's the most number of hours an employee can work. Whoops, what happened there? I guess I touched it funny. That's the most number of hours an employee can work without getting any overtime. Now let me say that again because I want to make sure you understand it. We're saying that the most number of hours that an employee can work without getting overtime is 40. So if they work 40 or less hours, they will get no overtime. If they work more than 40 hours, they will get overtime. If they work exactly 40 hours, they will get no overtime. All right? I tend to use examples like this one when I'm trying to teach these concepts to people because by and large, even if you've never worked at a position where you're an hourly employee, most people can look at that and understand what's being discussed. Finally, we've got the overtime rate, which is time and a half. Time and a half is 150%. 150% comes out to 1.5. So hopefully everything that's in here for these program constants, they make sense. All right. Then we've got our instance variables. Remember hours worked and hourly rate? We talked about that. That if you're an hourly employee, you're going to work a certain number of hours a week. You're going to make a certain amount per hour. So these are the variables that we created for those. And remember, the hours worked must be between min hours and max hours, or 0 and 84. The hourly rate must be between min rate and max rate, so between 0 and 1,000. All right. Then we have our object initializers. Now you'll notice that unlike the example that we looked at before, here in our set routine, we are actually working and doing some input validation. So for our get, we just return the hours worked. But for our set, what we're saying here in English is if you worked greater than or equal to 0 hours and you work less than or equal to 84 hours, you put in a valid value. But if you did not, you put in an invalid value. So either you put in a number that was less than 0 or that was greater than 84. So if that's the case, reset the hours worked to the default, which is 40. Okay? Then we do a similar thing here with hourly rate. For the get routine, we simply return that hourly rate. But for the set, we again check. If the hourly rate that we entered in there, that's saying if it's greater than or equal to 0 and it's less than or equal to 1,000. So if that's the case, it's valid. So remember what comes after the question mark is the true action. So we take value and we assign it to hourly rate. But if we hit this, that means that we either put in a number that was less than 0 or we put in a number that's greater than 1,000. So we set the default rate, and the default rate happens to be 10. All right? And the last thing, not the last thing, I'm sorry. Here we've got now notice it says 5-parameter constructor. This looks a little bit strange. In fact, I'm going to hit enter here because I want to make sure you can see all of this. All right. The only part of these first, last, code, hours, and rate, so there's 5 parameters in here. The only parameters that this routine, that this constructor is handling are hours and rate, because those are the only 2 variables that we have in there, are hours worked and hourly rate. So these other 3, the first name, the last name, and the employee code, what we're telling the system here with this colon base in English is what we're saying is, hey, we want the parent child, remember the parent child of hourly employee is employee, we want the parent of the child to handle the first name, to handle the last name, and to handle the code. Now, for example, when you work in Java, you don't use colon base like this. You use the word super. And again, every language is different as far as how they handle all this stuff. The idea of how they're being handled is similar, but syntactically, the verbiage, etc. they use is going to differ. So, for this constructor, all we're doing is we're saying, hey, first, grab that first name that we called, and inside of here, which is our employee class, that's going to set the first name, that value. Then that last name that you have in here, again, call the employee class, and that's going to set the last name. Then for that code that you set or brought in, again, go back to the employee class, and there's the code. So that's how we're handling the first 3 parameters. And the last 2, or the other 2, I should say, hours and rate, we're just going to handle them like this. And you might say, well, you know what? You didn't do any validation there. I guess you could make a case that no, I didn't. Okay? All right. Now, the other thing that's in here, again, it's very similar to what we looked at before. I'm going to close this so it's a little easier for you to see what's going on here. There is our overridden toString method. All right. Now, hopefully you remember this. I'm going to run this one more time. So let me save this and run this one more time. All right. You saw what all this looked like. But now we can see the whole shebang, so to speak. All right. We've got there what? Hourly employee. Okay. And then we got a 0 here. Well, what the heck is that? 0. backslash n, and then a 1, all right, and then a 2, etc. What does all this mean? Well, this means here where we've got this hourly employee and we've got the :0, that's going to combine the first name and the last name into one field. Where we've got the 1 right here, we're going to say employee code there, and we're going to pass in the code. And then for the 2, the 3, and the 4, the 2 is the hours worked that we just, all right, that's that hours worked that we inputted. Then the 3 is the hourly rate that we input. I'm sorry, I should say this again. We've got 2 : F2. That's the hours worked that's right here. That. And the 4 that's right there, that's going to end up being, when we get done, that'll end up being the hourly rate. And notice that this one says :F2, which means we want to put the hours worked with 2 decimal places. And this one says 4:C, which means we want currency. All right. Now, when we calculate the gross pay, and you can see this because it takes up the rest of the screen here. In English, what we're saying here is, if the person worked less than or equal to 40 hours, give them straight time. Otherwise, figure out their overtime. So they get 40 hours times their regular rate plus whatever number of overtime hours they worked times their regular rate times 1.5, which is the overtime rate. All right. Now, like I said, that was done pretty quickly. It may or may not have made sense. So going back one more time then to our calling program, in main, we are instantiating here, creating, instantiating, whatever you want to call it. But we are creating 6 of these employee objects. 1, 2, 3, 4, 5, and the other one is, you'll see in just a second. So each employee object that we create is going to have a first name, is going to have a last name, and is going to have an employee code. Those are all going to be handled by our abstract employee class. The last 2 values that you see there, for instance, 50 and 20, those 2 values, these are the hours worked and the hourly rate. All right, and it could be backwards. I don't remember which order. So let's take one more look. It is hours worked and hourly rate, so that is correct. So again, if we look here at our answers, we've got Mike White. 50 was the hours worked, 20 was the hourly rate. 50 times 20 would be 1,000, but remember, 40 times 20, that's his straight time, okay? So that's 800, but he worked 10 overtime hours. 10 times 20 times 1.5 is 300. 800 plus 300 is 1,100. Then we've got our next employee in here. Now, we made mistakes in this employee on purpose. June Stone, with an employee code of 1, worked 150 hours, which is out of range, and she makes $10,000 per hour, which is out of range. So right here, this 150 was reset to our default of 40. This 10,000 was reset to our default of 10. 40 times 10 is 400. All right, and I got to change some of these comments in here that I put. Okay, so this should say test of valid. Oops, these should all say hourly. Yes. All right, so again, we've got 6 employees. The first one, valid, valid. The second one, invalid, invalid. And as you saw when we did this, now I guess I closed it, but as you saw for the second employee that we had there, all right, this one, June Stone, was reset to the default values. Then our third one was valid, valid, so that's 400. Our fourth one, right there, we wanted to make sure that the overtime was set, and it is. Our fifth one, we wanted to make sure the overtime was set, and it is. And for the last one, we had no overtime and no extra hours to make sure that was okay, and it was. And again, so right here, where I wrote create subclass objects, I should have put a comment here like, I should have put a comment there that said something like instantiate, instantiate employee, hourly employee objects, because that's exactly what we're doing. And then we come in here and we create an array to hold those 6 objects. That's right here. We didn't have to say employee right there. We could have said hourly employee, bracket, bracket, hourly employees equal new hourly employee 6. We could have done that, and then these would have changed. The reason I left it like this is if we had other types of employees, and that's what I had in this example originally, I had 2 hourly employees, 2 commission employees, and 2 piecework employees. You'd have to write classes, so you'd have to write a commission employee class, and you would have to write a piecework employee class. I've done those, but I'm not making those available. All right. Then here, we're initializing that array that we called employees with those 6 hourly employee objects. Then we're going through a for each loop, and we're calling right here, whether you realize this or not, this line, that's the important one. This is calling the toString that we had over here. And for the base, okay, that is calling the toString from there. So that's going to put in the employee code, the first name and the last name, and the employee code. Then in here, we're going to put in the hours worked and the hourly rate. And in here, we go in and we add the gross pay. And notice this is a call. Emp is each emp, so that's each individual employee. So for each employee, we're calling the gross pay method. You already know what that is because we just looked at that in here. So again, I'm not going to say this is the best program ever or the best written program ever, but the idea is, at least in my opinion, it did do a job of showing you how to go and how to create a base class, also known as a parent class, okay? And that parent class was also an abstract class, in this case, the employee class. It also showed you how to create a derived class, also known as a subclass or child class. And in this case, since we were creating members of that class, since we actually instantiated hourly employees, that's also called the concrete class. So that's what this particular example was supposed to get across to you. And I hope that it did. All right. So when I come back, I'm going to be going over some examples from another chapter.